If you like my content, please like, share and subscribe.
Hello guys, welcome back to my new video. In my last video I have talked about NumPy, which is numerical Python. So I have talked entirely about NumPy libraries, what this NumPy is able to achieve. It is extensive use of methods and attributes. So today I will go further towards the data science world and show you what is meant by pandas and how you can leverage pandas libraries, pandas methods and attributes to get an insight of data. It's a very powerful data manipulation tool that is going to be used extensively in any data science project, and every data science skill sets requires pandas heavily. So pandas is basically, it's a fast, powerful, flexible and easy to use open source data analysis and manipulation tool. So it's basically built on top of the Python programming language. Where actually you are going to use pandas. So that is what I'm going to tell you today. So the very first step that we are going to see in pandas is series and data frame. So what we call as a series and what we call as a data frame, that we're going to see. So series is basically a one-dimensional labeled array, okay, which is capable of holding many data types like integer, float, string, and etc. So first we'll see what is series and how to create it, right? Great. So I'll just say this and so first I'll import what we call as pandas, okay, as PD, and also we will import numpy as well. So these are the two steps. So again, like if you have not installed pandas, so you can just say pip install pandas. So very it's the same as numpy and other Python modules as well. So you just have to say pip install pandas. That's it. If it has not been installed already, installed in your system, use pip install pandas. Don't worry, I'll share this notebook with you guys. I'll share the collab link of this notebook and you can then see from there. So okay, so the very first step is to import pandas and numpy, right? So I'll just say pd series. Okay, so this series is basically pd dot, if you do s you'll see that series. So this is the method that we have to use to basically create a series. Okay, so let's say series equals to and this, and then you can here you can say data and then say index. You have an index parameter as well, and then you have to pass some index. Okay, I'll say maybe this 1 2 3, okay, 4, and so this is basically a structure that you have to use to create the series. Now what is data? So this data can be of three types. Okay, so you can pass data as like numpy nd array. Okay, so this data can be numpy nd array. I'll just make it code markdown basically, and then you can use this data as dictionary. Okay, and also you can use this data as a scalar value, right? Okay, so we'll see how you can use these three types to create the series. Okay, so this is basically a type, it's not the actual declaration. So now I'll say this series and here I'll pass some numpy nd array. Okay, so as we already know that we can use this random module, right, and generate some random normal number, let's say 5. Okay, I'll create 5. So the very important step is whenever you are using this numpy nd array, the index should be should be of same length. Okay, so here we are generating 5 numbers basically, but then like in index also you have to put 5. Okay, now you can also omit this index. Okay, in that case Python will automatically assign some integer value to that index. Okay, so first let me remove it and say series, and now if I try to see the series, and then I will see that Python automatically induced this series 0 1 2 3 4, and this 5 numbers is basically the numbers that I have generated using this random. Okay, so since we did not pass any index, it is automatically adjusted some index, introduced some indexed basically. Now you can use a default index, or like you can explicitly pass some index. So for that I'll just say series index equals to will be like, I'll say index equals to, you have to pass this index in a like in a list basically. So you can just say C and then say D and then you can say E. Okay, so if you do this, now if you see the series, then the index is now ABCDE basically, instead of 0 1 2 3 4, right? So this is the kind of stuff that you can use during creation of any pandas series. Now this is the first method that we have used to create a series using ND array, right? Now I can say the second method will be this dictionary. I'll change it to dictionary and then I'll say hash hash. Okay, and here also I'll change it and I'll say hash hash. Okay, so now if it's dictionary, then you don't have to pass the index itself, because it will be, the order will be the same as of the dictionary. So I'll show you what it means. So basically if you say series 1, okay, and then say pd dot series. So first of all, like, create a dictionary basically. Okay, so let's say we have the dictionary as like a equals to, let's say, 12, b equals to, so I mean like a is a key and 12 is a value, b is key and 13 is the value, c is another key and 14 is the value. Okay, so now if you use this dictionary to create a series, then see what will happen. So like if you do this series 1 equals to pd dot series, and then you just pass this dictionary. Okay, you don't have to pass any index. What it will do, it will basically, this value will be the series value and abc will be the index as it is in the dictionary. So the order of the dictionary will be the same order how in the series 1 it has been displayed. So this is it. So basically abc are now the index. Okay, so this is dictionary. Now you can use data as a scalar value as well. Let's say 5 or 10 something. I'll change it to markdown, and then I'll do series underscore 2, and I'll say pd dot series, and I'll pass some value 5. Okay, and then I'll say index equals to, let's say, 1 2 3 4. Okay, now if you see, this 5 will be repeated 4 times because we have this 4 indexes. Okay, okay, so you'll see that. So this is how you can create your series. So there are the 3 steps that you can use to create your series. Okay, also instead of this you can also use another stuff like this, basically index equals to list of a b c d. That will also work, something like that. Okay, sorry, I'll say this. Yeah, Yeah, I have to pass E as well. Yeah, this should also work. So like if you see now this series, this is also will see A B C D E as index. Okay, so instead of this list you can just say use this method as well, just to like create a new list, nothing else. Okay, so these are the three types that you can use, three methods that you can use to create a series, Pandas series. Now series is very similar to what, as I called, as I told you, it's very similar to NumPy array. Okay, so you can do slicing, you can access the values using the index. Okay, so these are the types. So and also it's very intuitive that you can use a series in any NumPy functions. It's almost for all the NumPy functions, series can be used as an argument. Okay, but like you have of methods also to like create a NumPy array from a series. Okay, so that is also you'll see. So now I will talk about some methodologies that you can perform using this series, or the methods that you have in a series data structure of pandas. Okay, so the first of all, like I'll create a series. Let's say I'll do pd dot series, and then I'll say np dot random dot random, and then I'll say maybe 10. Okay, and I'll not put any indexes as of now. So now if you see the type, it should be series, right? Yeah, so it's core series. Okay, but you can create a numpy array out of it. So just use this h dot to underscore numpy, basically this method, and you will see that a numpy array has been returned. So if you just say n array, okay, and see the type of n array, you will see that it's a numpy nd array. Okay, so this is basically a very quick way to move a series to a numpy. Okay, numpy array basically. Now you can use data types. So d types is a I think it's a attribute to see what data types this series is holding. So it's basically a float 64. Okay, so I'll just show you the data here in S. It's a float 64, so you can directly get it using this dtypes attribute, right? Yeah, and like now you can use like index to access the data. So like if you want to access this 1.6680, you can just say s of 0, and you will see that it's working the same as like what we have seen in numpy nd array or list, right? You can also do a slicing. You can say slash and then colon 3. You will see the first three elements. Again, Python indexing starts from 0, so 0 1 2 are the top three elements. Okay, you can similarly do 3 colon as well. So you will see that starting from 3 until the end of the array, so you'll see all the values. Okay, so these are the types of operations that you can also perform in series. You can say like similar to list, you can also say filter basically this series s using like greater than or less than. So you can just say, if you, since you have this, now if you just want to see what are the elements that are greater than 0, right? So if you just say s greater than 0 and run it, you will see that these are the 4 elements that are greater than 0. So you can use this type of thing, and also maybe you can just say what are the elements that are more than the mean. Okay, so you can just do this. So you'll see that these are the 5 elements that are more than the mean of this series. Okay, you can also filter using a list inside this series. Okay, so just using the index you can filter out existing series as well. So let's say you have this s series, and now you want to only get one, like you want to only see the value of 1, 5 and 9, let's say. Okay, so you can just do then inside this another list and say just provide the index 1, 5 and 9. So you'll get filtered index, filtered series using this index as well. Now we're going to talk about data frame, which is the most commonly used data structure that you are going to see in any data science or machine learning projects. Okay, so what is data frame? So data frame is basically a two-dimensional labeled data structure. Okay, very important, labeled data structure with potentially like different attributes of columns. Okay, so like you can think of a data frame as a like a spreadsheet or a excel file or a sql table. Okay, which has many columns, and each columns can have one data type, but different columns can have different data types as well. Okay, so this is basically data frame. It's a very popular object data structure in Pandas, and you are going to use it extensively in any project of data science or machine learning. Okay, now I will I will show you how you can create your data frame, how you can generate your data frame from the raw data, from the like data that you are going to be given, or you can create your own data and create your own data frame out of it as well. Okay, so there are like many steps that you can use to create data frames. Okay, so firstly you can say that using dictionary. Okay, dictionary of like numpy array, generally numpy nd array we can say. Okay, then you can use dictionary of lists to create data frame as well, and also like dictionary of series as well. So like the first step is basically using dictionary of numpy array, let's say. Okay, so we'll add one cell and say, so like I'll create a dictionary basically, let's say this. Okay, so here I'll say the first key will be 1, and then I can say the value will be, let's say, pd dot series. Okay, and you can say like np dot random, let's say 4. Okay, now the next I can say 2, next key will be 2, and then again the value will be, let's say, a string, let's say 1a, let's say b, then c, then d again, and then e. Okay, so this is my basically dictionary. Okay, so I'll just say my data frame is equals to pd dot data frame. Okay, so this is data frame, and I'll simply pass d. Okay, so here I have some error which says that array length 5 does not match index 4. Okay, so basically what we have to do is I have to pass, this is 4, I have to pass 5 here. Okay, now we are all good. So we can see data frame, we'll see the data frame as. So now if you see that this is my first column, 1 is my first column and 2 is my second column. Okay, so this is like that, and index is like 0 1 2 3 4, which is like similar to series, where you can say that like this is auto assigned by the Python library. Okay, now if you want to like introduce your custom index, then what you can do is you can do something like this. So this pd dot series. Okay, and then you will say that so here I'll also introduce pd dot series as well. Okay, and this pd dot series I'll introduce, and I'll also say index equals to, I'll say a, let's say b, and let's say c, and also d. I guess I have 5, so I'll have to add one more, e. Okay, so this is for 1, and similarly I can say 2 as well, where I'll do 2 will be let's say, yeah, a b c d e. Okay, so if I now do this, and now again I'll try to create a data frame out of it, I'll say this d, So this t is basically this, and yeah, I ran it. Yeah. So now if you see this data frame, you will see that I have a b c d e, my custom index. Okay, but like if you remove one of them, let's say if you remove e and you place 4 here, okay, and now run it, you will see that this fifth index, which is there for column 2 but not for 1, will be set as NaN, which is not a number. Okay, so you will see that E1 is NaN because I did not pass E here. Okay, the last index basically. So this is basically, you can use in dictionary in this way to create your data frame. Okay, so here we have used dictionary with series. So similarly you can use dictionary with list as well. So let's say I have a dictionary called this, and I'll say that A, basically our first column 1, I can say. Okay, so column 1 is basically, let's say, a list of uh, number 10, 20, 30, 40, 50. So here I have used using dictionary of numpy nd array. Okay, I'll say here dictionary of list, basically dictionary of list. Okay, and I'll change it to markdown. I'll just put a heading out of it, and then my next method will be dictionary of series basically. Okay, I'll change it to markdown, and I'll do that. So now I have this list with me, column 1, and I'll say column 2 as some other number, let's say like that, column 2. Okay, and I'll push here, let's say 100, 200, 300, 400, and 500. Okay, it's very easy to create a dictionary out of it, and now it's even easier to create a data frame as well. So you can just say data frame and you pass D. Okay, so now if you run it, you will see that it's a column 1 with these values, column 2 with these values. So very similarly you can use numpy array as well here to create your data frame. So this is like creating data frame with series of dictionary. This is like creating a data frame from reading dictionary of lists and dictionary of numpy array, basically I can say numpy nd array. Okay, so this is also very similar. So now I'll show you one quick example of it. I'll just say, instead of this, I'll say np.array. Okay, I'll pass here this, and column 2 will also be np.array. I'll pass this as well. Okay, right, I have this dictionary created now of numpy array, and again I'll say data frame equals to pd dot data frame, and I'll say D. Okay, so now you'll see that a similar value, similar set of values in data frame. Okay, so these are the 3 types you can use to create a data frame. Now suppose you want to create another data frame, okay, from an existing data frame. So what you can do is so this data frame you already created, right? I'll just show you here. Okay, I'll say like this, and I'll just for the sake of readability, I have kind of like this. Okay, so this is my data frame. I'll say I'll just use E as well here. Okay, and I'll say 5. Right, so I have created this dictionary, and I'll say data frame new, and I'll say pd dot data frame, and I'll pass my data D. Now I only want, so basically I'll create a data frame new here. Okay, so this data frame new is there. Okay, so it has all these columns. Now I want to create df like 2. Okay, and here I just want to keep A, C, and E, only these 3 columns, only these 3 indexes, and let's say I'll interchange 2 and 1. So 2 will be my first column, 1 will be my second column. So how you can do that? So you can just use this same dictionary data frame. You pass your dictionary, you pass index explicitly, and you just say A, C and E. Okay, and columns also is a argument here. You can pass columns and you can just interchange. 2 will be my first column and 1 will be my second column. Okay, so if you do that, now if you try to see df2, you will see that it has been interchanged. So 2 is now here, 1 is now after 2, and we have only A, C and E, these three indexes. So this is another way of creating data frame. Okay, so like there are many other ways. As I go along with this tutorial, I'll show you another some other methods as well. Okay, but these are the very basic data frame creations techniques that you have to use, you have to keep in mind. Now it's very important to note that how you can access your indexes or columns, okay, of a data frame. So it's very important because you need it frequently in your future projects. So like, so if you have this df2, how you can use df2 to access your indexes. Okay, so you can just say df2 dot index. So these index is basically an attribute. So if you do that, you will see that ACE are my indexes. Okay, so it is basically in this format, but if you just do list of this, you will see that sorry, I just need to remove this and I'll see. So you will see that it's a ACE, a list of indexes you'll get already. Okay, so similarly to these indexes, you can also have columns basically. So if you do columns, you will see that 2 and 1. So index and columns are very two different attributes and very important. Now one more important way of creating a data frame is like using from dict. Okay, so you can just have pd dot data frame. Okay, and then you have this method called from dict. So this is also an important method. So you have to use this from dict in such a way that it will create a data frame. Okay, so from dict is basically dictionary, so you can easily understand that we have to pass an dictionary as an input, as an argument to this from dict, right? So here I'll just say dict. So this is my dict keyword that we can use to create a dictionary. So this is basically my dict. Okay, and now here you have to pass what? You have to pass the list, basically list of tuples. Okay, so this is my list of tuples. So here I'll pass one column and value, and in the next tuple I'll pass another column and value. Okay, so here I'll say my first column, and then the values will be in the list as well. So I'll say 1 2 3, and here in my second column, which is B, I'll pass another 3 values, which is 4 5 6. So if you run it, so here I'll have to say that this should be comma. Okay, it should not be colon, this should be comma. Yes, right, yeah. So here we have what? We have this A column, and 1 2 3 are the values, and B column is 4 5 6 are the values. So here we have a catch, like there is a parameter called orient. Okay, if you do a shift tab, you will see that a parameter called orient. Okay, so by default it's column. Okay, so basically what it means is, like, if you do not pass orient, the A will be treated as column, B will be treated as another column, right? But like if you pass this orient, and then you have to say this column basically. So if you say orient is index, okay, so then this 1 2 3 will be a row, and then 4 5 6 will be another row. Okay, so for that you have to pass this orient as index, and if you check another, you have to pass these columns here basically. Okay, so you pass columns as, let's say, in a list, let's say small a, small b and small c. Okay, so here what will happen is this will be treated as columns, These will be the values 1, 2, 3, and 4, 5, 6, and A and B will be the index, right? Yeah, absolutely. So let me do that. I'll not change this one. I'll keep it as it is, whatever was the original. Okay, like that. Yes, yeah. And here what I did is, like, I pushed orient as index, and I have explicitly mentioned the column names. Okay, so now if you see, okay, so this index I have to put it in a string. Okay, now if you see that now ABC are the column names, AB became the indexes, and 1, 2, 3, 4, 5, 6 are the values. So these way you can use your from dict method and dictionary as an input to create your data frame. Okay, great. Now we will see how you can select a column, or maybe add a column, insert a column, or delete a column. Okay, so these are very important. So I'll say how to select, add slash insert, or delete a column or columns. Okay, so yeah, I'll change it to markdown again, and I'll say triple hash. Okay, so now first of all I'll create a beautiful data frame. So I'll say data frame, my data frame, and I'll say pd dot data frame, and I'll pass a dictionary. Okay, so I'll say np dot yeah, I'll do dict basically, and or maybe I'll just say I'll create a dictionary first. Let's say like that. Yeah, my dictionary will be like this. So let's say np dot random dot random. Okay, I'll say 5 6. Okay, and this is my value, and my column will be, let's say, numeric is my column. I have to change it, yeah, something like that. So numeric is my first column. Okay, categorical, I can just say categorical is my second column, where I'll just say a list of values. So I'll say 1, say 2. Okay, then I'll say 3, I'll say 4. Okay, and then I'll say 5, and then I'll say 6. Perfect. So I have created these two, let's say something like that, this dictionary. Yes, okay, perfect. Now I'll create my data frame with this dictionary, and now if you see this, this is my dictionary. Okay, okay, perfect. Now if you want to select only the numeric, how you can see only the numeric values? So you can just say my data frame, and then you will pass numeric here. Okay, so we'll see that only the numeric values as a series. This will return a series. Okay, so suppose if you have this s equals to this, and now if you want to see the type of s, you will see that it's a series. Okay, so this way you can access a column, entire column, using this. And also there is one more option that you can use to again access the series, is like dot and the column name. It will return the same value. Okay, the same values will be returned basically. And so similarly you can use categorical as well here. So you can just say categorical, and it will be 1 2 3 4 5 6. Okay, perfect. So this way you can use your columns for selection. Okay, now suppose you want to add a new column, let's say alphanumeric, in the position, in the first position, that is between numeric and categorical. So you can do insert. Okay, so insert you can use. So again, just check the documentation. So here you will see that location, the first will be the location, second will be the value of the column, like the name of the column, and third will be the value. Okay, so let's say I'll have to insert it in the position 1. I'll have the column's name, which is, let's say, alpha numeric. Okay, and then in the values, I think, right, in the value you can just say a list where it will be like alphanumeric will be first, will be 1, then I have a, and then then I have 2, then b, and then I have c 3, and then I have c. Okay, so now if you want to see my data frame, you will see that alphanumeric has been added. Oh, right, and it has been added on the first position. Okay, perfect. So this way you can add or insert. Okay, now you want to delete this alphanumeric. What you can do, so you can use this del command. Okay, so you have this del, so del, and then you have to pass your data frame name, and you have to pass your basically the column name. Okay, so this way it will delete my data frame, this alphanumeric from the data frame as well. Okay, now you can do one more stuff, is like pop. Okay, so you can just say my data frame dot pop, I think, yeah, pop, and then you have to pass your column name. Let's say categorical I want to delete, I'll just say categorical, and this will return something. So if you just want to see that what it returns, you will see that it returns basically series. Okay, so you can just, so it will basically return this 1 2 3 4 5 6. Okay, so you'll just set it here, and now if you want to see my data frame, you will see that only one numeric left. Perfect. So this way you can delete. So now you can add, like add column. So we have inserted the columns, right, but we did not add. So you can add a column maybe. So you will just say that numeric plus 1, you want to plus 1. So this will be your next column that you want to add, right? So you can just say like this, which will be this data frame name basically, and then this is my column, new column, and I'll just say that my data frame dot numeric, okay, plus 1. So if you do this, now if you want to see my data frame, you will see that numeric plus 1 has been added. Okay, so this is a new column we have added, and I have just, what I did is like I have added 1 for each row of this numeric column. So if you see that 0.07, it's 1.07, something like that. So like 0.32, so I have added 1, so it is a now positive value. So it added like 1 to each of the rows and created a new column out of it. Perfect. Okay, now two very important methods in pandas is like lock and ilock, where in lock you have to use lock for selection of any columns by labels. Okay, the column names basically, or the row names, and ilock is basically to access data frame values using the index. Okay, so lock and ilock, these two are very important methods. Okay, so you have to keep this in mind always. So lock and ilock. Okay, so for that I'll quickly create a data frame. Okay, so there is a concept of data frame called date range. Okay, so if you use that date range, so you can just pass the first date, basically I'll say 2022 0101. Okay, in a string, and I'll say periods should be 6. Okay, so now if I see, we have like 6 values of these dates. Okay, so these dates, like you can see that it's a date time index. Okay, so this is basically a data type of our date field basically. Okay, so these dates, I'll use these dates as an index of our data frame. Okay, so now I'll just say that I have my data frame. Okay, and here I'll just say pd dot data frame, and I'll pass the data as random dot rand n, and I'll say 6 by 4. Okay, so this will be my size of this data frame. Index I'll pass as dates. Okay, and columns I'll choose as, let's say, ABCD. Okay, ABCDE, ABCD, yeah, like that. Okay, perfect. So now if I see the data frame, I have this ABCD, 4 columns, 6 rows, and our index is basically 6 index. Okay, so now I'll use basically selection by labels and selection by index. So selection by labels will be lock. Okay, so I'll just use selection by labels, selection by labels. This will use lock, and this is 1. Okay, I'll just say it as a markdown. Okay, yeah. Now suppose you want to use you want to access the first row of this data frame. How you can do that? So you can say data frame dot lock. Okay, and say dates is my column, right? Date is my index, right? So I'll pass 0, which is this one, basically the first row. So if I do that, so this error is basically I have to, this is in the lock, I have to pass like this. Okay, the first row in a series format. Okay, so if you see, first row is 0.87, and then we have 0.07, then we have 1.56 and 1.27. Okay, so this way you can use lock. Now suppose you want to use you want to say access basically the first 2 columns. Okay, so how you can do that? So you have to, like, you want all the rows but only first 2 columns. So similarly, using lock, how you can do is it's this a lock, and then you have to pass. So we have to pass 2 things, right? The rows and the columns, and it has to be separated by comma. Okay, so I want all the rows, so I'll say colon, similar to what we have in lists or numpy array or series. Okay, so here also you can use colon for all the rows, and I just want 2 columns, basically A and B, right? So I'll pass it in a list, basically like that. Okay, yeah. So now you will see that we have all the rows but only 2 columns, A and B. Now if you want to, like, access only few rows but for A and B columns, how you can do that? You can similarly use this date, and instead of all row you can just pass the this one, right, this index basically. So if you want only the 2 index, so you can just say this one and this one. Okay, so this way you will see that we are getting only 2 columns A and B, and for the first 2 rows. So all the endpoints will be included in lock. Okay, so basically since we are not using index, so the endpoints, like B is the endpoint here, so it will be included. Also the last row is also included, right? So endpoints will be included in lock. That is very important, please keep this in mind. Now if you want to, like, access a scalar value, okay, let's say you want to access the value of this 3.20. Okay, so how you can do that? So again you can just say data frame dot lock, okay, and so this is 3.2. So what's the row? It's the second row basically. So I'll say dates 1, right? This is my second row, and column is B column, right? So I'll just say B like that. Okay, so you'll access 3.20. So it's a scalar value, the way of accessing a scalar value, right? Yeah. Now the a faster way of accessing this scalar value is using at. Okay, so we have this at, see this at, and similar to this arguments you have to pass this only, and sorry, I'll just say this. Yeah, so we'll see that. So this method is little faster in order to access a scalar value. So these way you can use lock to basically access your data frame slices or data frame vectors or data frame scalar values. Now we will use ilock. Okay, so this is my second method. So now if you want to basically select, let's say I'll just print the data frame again here for your convenience. Okay, so now if you want to select on the second row, okay, so this, so here what you can do is you can just say data frame and dot ilock. Okay, I'll pass now the indexes of columns and rows basically. So this is my first row, so I'll say 0. Okay, and this is my second column, right? So I'll say second. Okay, so this is the value 0.07. You will see that so 0 2, so this is 0, the 0 and this 2 basically, so this one, right? So yeah, it will be here. Okay, so similar to so like if you want like some more columns and more rows, so suppose you want first 3 rows and last 3 columns, so what you can do is again you can just say data frame dot ilock, and then you want first 3, right? So colon 3. So again, this is very important that ilock does not include the endpoint. Okay, it will act similar to what we have seen in lists and numpy array, that if you use indexes then the endpoint is not included. So colon 3 will only fetch first 3 rows, okay, 0 1 2, and you want last 3 columns, so I can just say 1 colon, okay, like that. So if you see 1 2 3 1 2 3 and BCD is coming, okay, so 1 to end of this columns. Okay, so this way you can use ilock as well to basically access our slicing of any data frames. Now I'll show you a couple of more examples, like if you want first 3 and first 3, sorry, you want like first column, first row, third row and fifth row. Okay, so you can just do this, and let's say you can just pass 1 2, let's say 1 3 and 5 you want to access, you can do this. Okay, and then you can pass 1 4 and 5, sorry, so you have 1 2 and let's say 6, 1 3 5, right? I have, and then I can say 0 2 and 3. Yeah, so yeah, so 0 2 and 3 is ACD basically, and 1 3 5 basically 1 is 2, 3 is 4, and then 6. Okay, so this way you can use something like this to access columns as well, which is not like consecutive columns basically, or consecutive rows. If you have the separated rows, you can use this way to access your data frame objects, data frame values. Again, for accessing a scalar value I showed you already, but to for a faster access you can use I at. So for lock you have at, but for ilock you can use at I at basically, so something like that, and then you can say 0 0. If you pass 0 0, you will get this this value 0 0, right? So this is for faster access, IAT. Okay, so these two methods are very important, lock and ilock. Please keep this in mind. Great. Now one concept is called Boolean indexing that I'll show you. So what is Boolean indexing? So this is basically, it is used to like filter a data frame using a columns value. Okay, so now, so suppose we have this data frame already with us. I'll again print it for you guys. Okay, right, yeah. Okay, so now, so what is this Boolean indexing? So like you can use a columns value, let's say df of a value. Okay, so I'll just say df, and I just want to see what are the values that are more than zeros. Okay, so suppose I'll just say df greater than 0. Okay, so yeah, it should be data frame instead of df. So I can just do this to find out that basically these are the values that are greater than zeros, and which are like in negative, these are coming as n. Okay, so which is not a number. This one more stuff, like just say that to keep only those numbers that are like greater than 0 for column A. Okay, you can do similar to that as well. So you can, if you do this and let's say column A. Okay, so it will this is not, this will not include any NaN. Only those columns will be, those rows and columns will be included that are having greater than 0 values, corresponding to column A values which are greater than 0 basically. So if you see column A values having greater than 0 are like second row, third row, fourth row and fifth row, right? Yeah, so second, yeah, second, third, fifth and sixth basically. So second, third, fifth and sixth. So corresponding BCD columns has also been kept. So this is a one way of saying that you did a Boolean indexing. Now there is a one more concept called is in. Okay, so you can do is in as well to filter a value using the Boolean indexing as well. So similar to, so like I'll create one, let's say I'll create one column. I say that it's e column basically, and which will be basically a value of, let's say 1 2 3 4 4 5. Okay, so if I do that and I'll just use some strings. Okay, now if I see my data frame, it will be having e column with this. Okay, so now I just want only those rows that are 1 2 and 4 basically. Okay, so I'll say data frame dot e is in, so I can say is in dot is in basically. Okay, is in, and then I'll pass 1 2 and 4. Okay, so I'll say 1 2 and 4. If I do that, yeah, so I'll see that only these many rows has been kept where the e values are only 1 2 and 4. Okay, so this is basically called Boolean indexing. So you can use this type of values or this type of conditions to filter a data frame. Okay, perfect. Now I'll show you how you can set some values into our existing data frame. So setting values into a data frame is also an important concept. Okay, so let's say I'll have again I'll create I create this date range basically. So I'll say s1 is equals to pd dot date range. Okay, I'll pass, let's say, a value called 2022 0101. Okay, and I'll say periods is against, let's say, 5. Okay, so now if I see S1, I'll see that I have 5 indexes, like 5 values of my date time index data types series, right? Perfect. So now if let's say I'll create a empty data frame which will be like df, and I'll say pd dot data frame, and I'll pass s1 basically. Okay, so now if I see df, I'll see that it's a, so these values are basically in here. Okay, right? So now again I want this now, I want this data, this dates in an index. Okay, so what I'll do is I'll just create this data frame where my index will be s1 and my data will be, let's say, 1 2 3 4 5 6. Okay, something like that, right? Yeah, so yeah, this is an error, so shape is mismatch, so it's 5, so I'm passing, so I have to pass 5 only. So now if you see df, so you'll see that it's a, this 1 2 3 4 5 is my value. Now I want to set this value 1 as 0. How you can do that? You can use this at method, right? We remember at method, and you can say my, so this is my s1, I'll say my first row, and then my 0 first column. Okay, and I'll pass it, I'll set it as 0. So now if you see df, you'll see that it has been set to 0. So similarly you can use iat also to do that. So if you want like this 3 to be, let's say, 10. Okay, so what I can do is iat, I'll pass 3 means, so second row, right? So I'll pass second, and the first column, 0th column. Okay, so I'll set it as 10. Now if you see df, it has been set to 10. So now if you want to assign another column with all the scalar values, like as fixed value or maybe some other values as well, so you can use a similar kind of settings as well, like setting a data to create a new column and then set some values as well. You can just say df dot lock and say colon and then new row, new maybe column name, and then you can just say np.array, np.array, and 5 into, so it's like 5 times the number will come, and with the len of df, so len of df is 5, right? So 5 times 5 is like basically 5 5 5 5 5 5. Basically if you see this will be np array of 5, 5 times np array. Okay, so like this. Okay, so now if you want to do that and see the df, it will have a new column called d, and all the elements of that column will be 5. So these are the basic settings that you can do to set any value to a existing data frame. Okay, perfect. So that is all I have today for Pandas part 1 video. So part 2 is going to be very important as well. So please stay tuned. Check out my previous videos as well, NumPys, to learn more about NumPys if you did not check it already. And I'll see you in my next videos. Till then, happy learning. And I'll also share this updated Python notebook with you in my description. Please check out and let me know in the comments below if you have any doubts or concerns.
If you like my content, please like, share and subscribe.